Alright guys, so we're going to go over the first section for quiz 15. It is a, challenging unit, mostly because there's a lot of information to it. So hopefully this video will help you guys all of our must-dos on it and make sure you complete the e-cart. I know it's online and a lot of you forget to do it. So let's go ahead and jump in. Alright. So a rational function, it is obviously a function with a numerator and denominator, aka it's a fraction. There's the top and the bottom, right? So the parent function, another way to think of a parent function, it's the default. Right? It's the most basic form of this type of function. So for example, the quadratics, all those parabolas, the parent function, the default function was x squared. Right? So every function has a default as a parent. So for rational functions, it's this 1 over x. Right? So the thing with 1 over x is that it's a fraction. And what we've seen in the last unit is that if I had a number divided by 0 and you put in your calculator, it gives you an error, which means x can never be 0. So for our parent function, we're going to call this an asymptote, and we'll talk about it further down. But an asymptote is something you can never touch, right? It can never be x equals 0. So when we graph it, we usually put like a small dash line just to remind ourselves that we will avoid putting anything this line. Right? X can never be 0. Right? Now, here we'll talk more about it, but we also have a horizontal asymptote, and we'll talk about what asymptotes are at y equals 0. So that's why I'm putting the dash lines here. We can never have a y equals 0. Because, for example, if I try to do that, if I put 0 for y and I have 1 over x, multiply x on both sides, anything times 0 is 0, and 0 is never 1. That's like mathematically impossible, right? 0 is 0, 1 is 1, but 0 can't be 1. So that's why we will never have a y equals 0 for the parent function. Okay? Then if you go ahead and put it in Desmos, you see that this is the general picture for our y equals 1 over x. Okay? We get super, super close to our asymptotes on all sides, but notice how we never touch it and we never cross over it. So like if I was going to trace this with my finger, I would go down, I'd have to pick up my pen, jump over x equals 0, and then continue tracing. Right? It's called discontinuity, and we'll talk about it in the next video. So the way we're going to do the notes for this section is everything in, let's say, green is going to be for in general, for any rational function. And then whatever I do in pink is going to relate only to the parent function, only to 1 over x. Okay? So how to find the x-intercepts. If I give you any rational function, right, there's two ways you could do it. The first way, like any time in Algebra 1, you could set y equal to 0 and then solve for x. Okay? That's if you wanted to find the x-intercepts. Or the easiest way for this is you set the numerator, or the top of your fraction, equal to 0 and solve. And I'm going to go ahead and star this one because this is the method you definitely want to use for any type of rational function. Just take the top, set equal to 0, and solve. Sometimes we'll have one, sometimes we don't. So now let's go ahead and look specifically for the x-intercept of 1 over x. Alright, so I'm going to take the top. So the top of my fraction is 1, and I set it equal to 0. and there's nothing to solve for, and 1 does not equal 0. So we have no x-intercept. So in this case, we don't have one. That's not always going to be the case. But the parent function does not have one. And you can see from our picture, we never cross the x-axis. Next up is the y-intercepts, right? This is for any rational function. Well, just like in algebra, we're going to set all of the x's equal to 0 and simplify / solve if we need to. Okay? So we're going to go ahead and try and do that for the parent function. Remember, this is technically y equals f of x and y are the same thing. So I'm going to set my y equal to 0. Oops, no, my bad. Have my y equals, and I'm going to put 0 in for x. But if we put that in our calculator, we notice we can't have that. It's impossible. So we have no y-intercept. We have no y-intercept for the parent function. Sometimes we can have one. But if we look at our picture that matches, there's no y-intercept. Next up, we have a vertical asymptote. Now, asymptote is a new term we're looking at, and that basically means it breaks your graph up, sometimes in 2 pieces, sometimes in 3 or more, and you will never ever touch it or cross it. So vertical asymptote is a discontinuity, and in math, discontinuity is just a fancy word of breaking up our graph. It's a vertical asymptote, so it's a vertical line. See how we did that? That the function that we never touch or cross. Right? We may approach it forever, we'll make it super, super close to it, but we'll never actually touch it or cross it. How to find a vertical asymptote, I'll put that down here. For any situation, we've actually been doing it. We did it in quiz 14 a lot. You take the denominator and set it equal to 0. So set denominator, or the bottom of your fraction, equal to 0, and solve. And the reason we do that is because we don't want a 0 in the denominator. So if we figure out what it makes, then we're like, cool, then it can never be that number. And that's how we get the asymptote. Like for here, we can't have 0 in the denominator. X was 0, which is why we made an asymptote at 0. Okay? So vertical asymptote for this case, the parent function, switch over to pink, take my denominator, which is just x, set it equal to 0 and solve. Well, by solving it, it's already done. So x can't be 0. There is our vertical asymptote. Right? X equals 0. Same thing. Let's go to a horizontal asymptote. Well, vertical asymptote was a vertical line we don't touch. Horizontal asymptote, if you can think about it, is a horizontal line. This one's a little weird because sometimes we can cross it. We'll see it on the next page. It's a horizontal line, and it talks about the end behavior. We only care about the ends. Right? If you remember back, that's the whole as x approaches infinity, what's y approaching, as x approaches negative infinity, what's your picture doing? Right? Sound familiar? I hope so. Let's clear this. All right. So the horizontal asymptote, we're actually going to see there's a whole chart on the next page. So right now, I'm just going to write it as 1 over x. And if you see, the x is on the bottom. So that automatically makes the y-intercept 0. And I know that's confusing, and we're going to see why on the next page. Okay? But for this case, for our parent function, it's y equals 0. Next up, we got domain and range. So domain is a discontinuity or broken up by looking at your vertical asymptotes and holes. We'll talk about holes in the next video. Okay? And the range is also a discontinuity or broken up by your horizontal asymptote. It's the only way you could break it up. So if I'm going to look at the domain for the parent function, default, I switched to pink. Always, 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 it even says it here, we start with negative infinity. So we're at negative infinity, I'm going, and I actually don't have x equals 0. So I'm going, and I pick up my pencil. There's my first break. It's a break at 0. So I'm going to put 0. And since we never touch this and we never cross it, we are going to use parentheses. We do not use a bracket. Then we put a U because it means union. That means the graph isn't done. There's a whole nother section. So we have this section, and now we have another section directly after 0. So I'm going to put 0 again, and then we go to the right forever. So infinity. That's the domain for the original default parent function, 1 over x. Okay. Now we're going to look at the range for the parent function. Just like the domain, we always start with negative infinity. And range is bottom to top. So I'm going. Here's my first break at y equals 0. So in this case, it's the same. They're not always going to be the same. Then a union, because right after 0, I have more of a picture, all the way up to infinity. So 0 up to infinity. In this case, they're the same. That's not always the case. We'll see it on the next page in a second. Well, actually, a couple minutes. I lied. Okay, so definitely we're going to have to reference this, but let's go ahead and flip over to the next page. So this is important if you're using calc. A calculator. Right? If you are using a calculator, you have to type the numerator, so the top, and the denominator, the bottom of your fraction in, switch colors because it's important, parentheses. If you're using Dev Notes, you don't need to worry about that. Just make sure you copy it correctly. But if you're using your calculator, the biggest thing people mistake are where they put the parentheses. Your calculator is super picky. Alright, so let's go ahead and look at this chart. So for some of you, we said to cross this chart out, but I'm sure depending on your teacher, that might not have been the case. So I'm going to go ahead and leave it. So we have 4 cases of a horizontal asymptote. A graph can only have one though. So you either have this case or this case. You cannot have all of them or 2 of them. You got to pick one. So the first one is if the equation is in standard form. That's just meaning if you have a fraction plus like a number or plus something else. If you have something added or subtracted on the side, then the asymptote, the end behavior, is whatever is being added or subtracted on the side. So we were adding a 4, so end behavior, the horizontal asymptote, is at y equals 4. That's your barrier. Next one up, we have if it's bottom heavy. We call it bottom heavy because if you look at the highest degree on top, in this case it's 1, and the highest degree on the bottom is a 2. the degree that's biggest is a 2, and that's on the bottom. So that's what makes it bottom heavy. Anytime it's bottom heavy, your horizontal asymptote is automatically 0. So those are your end behaviors. Mr. A likes to say Bobo. Bottom, what does he say? Let's see, bottom bigger, it's a 0. So if bottom's bigger, then it's 0. If you want to come up with a different way of remembering it, that's fine. Totally go for it. The next possibility is top heavy, which if you can think of it, it's the opposite of the one we just did. If the highest degree is bigger on the top than it is on the bottom, like for this case, the highest degree is 3 and it's on top versus the 1 on the bottom, this is top heavy. And whenever you're top heavy, there's no horizontal asymptotes, which means the end behaviors just go to infinity forever. Okay? No horizontal asymptote. The last case, right, we had bottom heavy, we had top heavy, something was added on the side, but what if they're the same? If the highest degree is the same on the top and bottom, what do we do? So here the highest degree is 1 on top, and the highest degree is 1 on the bottom. So when that happens, we take the leading coefficients. That just means you take the numbers in front. So in front of x to the first is a 5, and in front of x to the first on the bottom is a 6. So we take those, and it becomes a fraction. It's 5 over 6. So the horizontal asymptote, the end behaviors, is to that decimal or fraction 5 over 6. We'll see some examples in a second. Okay. So our first example, we have x squared over x squared plus 1. We're going to have to find everything, and if we need to reference the other pages, we can. First step is to find the 0, but if you look, the 0 and x-intercepts, remember, those are the same thing. So if you find one, you've automatically found the other. Less work that way. So if we look back on the first page, if we want to find a 0 or an x-intercept, we either set the y equal to 0 and solve, or we're going to set the top, the numerator, equal to 0 and solve. So I'm going to do that. I'm going to take the top of our fraction, x squared, and I'm going to set it equal to 0. Now I need to solve. I'm going to undo a square with a square root, and it turns out that the square root of 0 is just 0, and there's no such thing as a negative 0. So we actually have an x-intercept in this case. That's 0, 0. I'm going to go ahead, I'm actually going to mark that down. Next up, we got the y-intercepts. And to find the y-intercept, you set x, all the x's, equal to 0. So we have y equals 0 squared divided by 0 squared plus 1. So that's 0 over 1. Anything divided by 0 is 0. Which makes sense because if our x-intercept's the origin, then the y-intercept is also the origin. That's the same point. Our horizontal asymptote, that's when we reference this chart up here. So I'm going to look at my highest degree on the top. That's a 2. And my highest degree on the bottom. It's also a 2. So if I look here, we fall in this category. The highest degrees are the same. So that's when we take the numbers in front and make it a fraction. So the number in front of x squared is 1, and the number in x squared is 1. So our horizontal asymptote is 1 over 1, which simplifies to 1. I'm going to go ahead, and if I draw that, it's an asymptote, so I'm not actually going to touch it, which is why I drew a dashed line and not a solid line, because I don't actually touch it. I'm going to skip the domain and range and first do the vertical asymptote. That's when we set the denominator equal to 0. So we have x squared minus 1, plus 1. I'm going to set it equal to 0. I'm going to try and solve. I can't factor that because it's a plus 1. So I'm going to try and solve for it. But I can't have a negative square root. oops, you guys can't see, it's imaginary. So technically, that means no vertical asymptote, right, because it's imaginary. So I actually don't have a vertical line that's dashed. Now, if you put this in Desmos, you can find out the picture of the graph. And if you look, the picture is actually really weird. It's like you're super close here, you dip down, go through 0, dip back up, and like follow through. Doesn't have to be perfect, but that's kind of the picture we're dealing with. Not all of them are going to look like this, but here's our example. Now domain. Domain goes with the vertical asymptotes. So I'm going to always start with negative infinity, and I'm going to go. But I never have a break. I don't even have a vertical asymptote, which means I'm just going to keep going forever. There's no break. So it's negative infinity to positive infinity. The range, if we look at it, it doesn't start from negative infinity because there's no arrow going down. So my actual first y value is 0. And yes, it's a bracket because I actually have a y at 0. And then I may go up forever, but I never go past 1. I don't even touch 1. So it's only 0 to 1. And since we never touch it, it's a parentheses. So our range in this case is 0 to 1. This problem, now that we're done with it, is like a super weird one. I just wanted you to be exposed to them. We're actually going to go ahead to the next one, and this is the type of problem that you're most likely going to see from us. Same steps. Remember, 0 and x-intercept, they're the same thing. So what I'm going to do is I'm going to take my numerator and set it equal to 0. So my numerator is 2. So I'm going to do 2 equals 0 and solve. But there's no x value to solve. And 2 isn't 0. So this means that there's no x-intercept. Right? Because it's impossible for 2 to ever actually equal 0. And there's no variable. Next, I'm going to find the y-intercept. The y-intercept is when you put in 0 for all of the x's. So I have a 2 over 0 minus 3 plus 4. This becomes 2 over negative 3 plus 4. And if we do some math, we are going to get 3 and 1/3. Okay, so that's our y-intercept. And you don't need to make it perfect, but it's a little above 2 or 3. Just gonna put a mark right there. Okay. Now I'm going to go ahead and find the horizontal asymptote. So I'm going to reference this chart. We have a fraction plus a number. So that falls in this category. And it's whatever number is being added or subtracted. So we are adding a 4. There's our horizontal asymptote. Y equals 4. So if I go to 4, I create a vertical asymptote. Boom, done. Okay. Now I'm going to skip domain and range and do a vertical asymptote, which means take my denominator, set it equal to 0, and solve. So if I add 3 on both sides, x equals 3. So x can never be 3. That's my vertical asymptote. So I go ahead and draw a dashed line. And there it is. So instead of this, we've now moved it and created new barriers. Okay? The rest of it, you can just go ahead and plug into Desmos or your calculator to get the picture or make a table. Right? So if we do that, you notice your graph is in 2 sections, from here and here. Notice how we never crossed or touched the asymptotes. Right? So our domain, always start from negative infinity. We go into our first break. and we have a break at x equals 3. Always domain is with vertical asymptotes. So we're at 3. I can't touch it, so it's parentheses, and there's 2 parts. So I need to have a union, and I need to finish my graph. It's right after 3, and I go forever. That's our domain. Our range is also going to start at negative infinity because this time we do have an arrow going down. And I go until the first break. We have a break at 4. So we go all the way until 4, union, and then directly after 4 and up, we still have a picture. So there's our range. I'm going to go ahead and stop the video here, but make sure you reference if you need to make flashcards, go ahead and do that.